So with all that said, we've come to the end of the course, and it's time for us to attempt to summarize every single pattern that we've seen, and there are a lot of them, so stay tuned for a comprehensive summary. So we're going to begin with the creational design patterns. So the first pattern we looked at was builder, and that is essentially the idea of making a separate component when object construction gets too complicated. So if you find that you are complicating the construction code of your object, maybe you have a constructor with too many arguments, or maybe some of those arguments become optional, or maybe there's too much logic in the constructor, then what you can do is you can take everything out and make a separate component called a builder. And keep in mind that you can have multiple builders which can mutually cooperate through a base class in order to have a nice interface for constructing the different facets of a single object. Now, builders typically have a fluent interface, which means you return this at the end of every single invocation. This certainly makes it easy for clients to construct your object in a single statement, while at the same time clearly being able to see the constituent parts which they are adding to the object itself. Then we looked at a similar concept. So if builder takes care of the sort of piecewise construction of an object, then a factory typically takes care of wholesale construction, meaning that it is in its functionality similar to a constructor. You call this thing just once and it constructs the object. And a factory method, which is a method for constructing an object, typically a static method, is more expressive than a constructor, as we have seen, because a factory method, for example, can have a name which is different from the name of the containing class, and it can also have overloads of similar arguments as a result. So you can have the argument names actually giving additional hints to the client about how the object is going to be constructed. And we saw that you can put the factory either as a standalone class right next to the object that's being constructed, or you can put it as an inner class, and the inner class has the benefit of accessing private members of the object it's constructing. So this benefits the encapsulation concept. Okay, then we looked at prototype, which is essentially the creation of an object from an existing object, and it requires one of two pieces of functionality. So either you provide deep copies, so you explicitly write code, and that can be an interface which says I have a member called deep copy, or that can be a copy constructor in the C++ style of reasoning, and that way you can copy the object fully, including all of its dependencies. Or the other alternative, the easier, shall we say, alternative, is to copy an object through serialization. So you serialize an object, and that serializes the entire object graph. So all the dependencies are going to be serialized, and then you deserialize it, and therefore you make a brand new copy not related to the previous copy of that particular object. Then we looked at the much maligned singleton design pattern, and the singleton is, well, it has its use, because sometimes you do want to ensure that just a single instance of a particular object exists. Now, there are certain concerns with the singleton, like, for example, how do you make it thread safe? How do you make it lazy? However, I've gone and just used a lazy of t straight away, and that kind of solves all the problems with the singleton without going too much in depth about the other approaches that came before it. Lazy of t in .NET Framework 4 is what fixes most of those problems for us. However, what you really should consider if you're using the singleton and you want testability and you want more flexibility in using the singleton, because actually hard coding the singleton into your code is very difficult to get rid of later on. So you should consider maybe extracting the singleton's interface and adding that as a constructor argument of some kind, or better yet, just use dependency injection, because every modern self-respecting dependency injection container actually has a lifetime, a component lifetime called singleton or single instance, and that is something that you can use to make singletons in a very kind of safe and understandable way. So you're communicating to everyone that you're making a singleton, and you're propagating it throughout the inheritance hierarchy. So using a singleton in a dependency injection container is probably the only socially acceptable way of actually using a singleton today.